Exploration. It is what people have done for centuries, from crossing the oceans destined to distant lands, to climbing the highest mountains and exploring the depths of the seas. We look to the heavens and dream that one day a human can survive the long journey into our solar system. It is for this dream today that NASA's Orion program is testing the limits of spaceflight. NASA is on a journey to send humans to Mars. In the midst of a stepping stone approach to getting humans to Mars, NASA is developing and testing technologies at progressively farther distances from Earth to ensure we have the right capabilities for such a mission. We are preparing for this first flight, currently designated Exploration Mission 1, in which the spacecraft will travel thousands of miles beyond the moon over the course of about 3 weeks. The Orion will launch in November 2018 on the most powerful rocket in the world and fly farther than any spacecraft built for humans. It will stay in space longer than any ship has done with astronauts without docking to a space station, and return home faster and hotter than ever before. The Orion EM-1 will be the first mission uncrewed, and it will be able to test out the Orion capabilities for this mission and push into the proving ground where we can demonstrate our human and technical capabilities for long-duration space exploration with the goal. The development team spans 2 continents, 7 countries, 8 defense contractors, numerous parts suppliers and subcontractors throughout the US and Europe. The NASA Glenn Research Center is an integral part of the Orion program, managing the integration effort with the rest of the Orion vehicle and conducting critical testing. The European Service Module is the powerhouse of Orion. Comprised of 4 solar array wings, the panels provide enough electricity to power 2 typical households, providing 120 volts of power for computers, experiments, and other hardware. It also serves as Orion's primary in-space propulsion system for the Orion vehicle and provides air to breathe, water to drink, and storage capabilities for future crews. The unpressurized cylindrical module is about 13 feet long by 6.5 feet high, including the main engines and the tanks for gas and propellant. During launch, it is held in place by NASA's spacecraft adapter and is connected to the capsule where the astronauts are by the crew module adapter. NASA Glenn Research Center constructed a test facility at Plumbrook Station to enable qualification of large spacecraft and was built to meet Orion's needs. This 3.5-year renovation project, using 14.1 million pounds of concrete and employing 125 workers, provides a one-stop human spaceflight environmental testing capability. In November 2015, the European Space Agency's contractor, Airbus Defence and Space, delivered a structural test article to NASA's Glenn's Plumbrook Station in Sandusky, Ohio, for critical environmental testing. It arrived at Cleveland Hopkins International Airport aboard the Antonov 124, a Russian airlift cargo aircraft capable of transporting up to 150 tons. The European structural test article only weighed 33 tons, well within the aircraft's limits, but filled every square inch of the aircraft's cargo hold, and required 4 semi-truck trailers to deliver the test article and support equipment for assembly to Plumbrook Space Power Facility. Immediately following delivery, the teams worked tirelessly to assemble the test article, a replica of the flight unit, for a rigorous series of tests that will ensure the successful flight of Orion, the next generation of human-rated spacecraft. The test campaign aims to analyze and validate every element and function of the structural test article, which represents Orion's power and life support systems. The first series of tests was to demonstrate the deployment of the solar array wing. The wing is constructed of 3 solar panels and when deployed, spans 63 feet tip to tip. On launch, the wing is folded inside the spacecraft, stowed in position by 4 Kevlar straps. To release the array wing, thermal knives cut the straps. Listen for the snap. Once deployed to orbit, the solar array wing must expand to allow the Orion vehicle to receive power. This test was an important first step to verify Orion's power system. The test confirmed that the array unfurled properly, locked into place, and that all of the mechanisms functioned as expected. Following the solar array wing deployment test, the structural test article was transferred to the acoustics chamber. The chamber is the most powerful in the world and mimics the launch environment that the Orion spacecraft will experience. The test was conducted to ensure the test article could withstand the force and pressure of the acoustics environment. When a powerful rocket launches, such as the Space Launch System, which will propel Orion into orbit, it can produce noise up to 180 decibels, levels so high it can vibrate and damage spacecraft components if they are not designed and built strong enough to withstand the environment. The maximum test lasts approximately 3 minutes. Microphones and sensors are placed in and around the test article to determine that the noise in the test chamber match the expected acoustic environment inside the service module. The test confirmed a sound design. The final series of tests in the campaign was the mechanical vibration test. This powerful spacecraft shaker system was used to assess the test article's ability to withstand the tremor that a launch will produce. In this test, we simulated what was predicted the test article would see by increasing and decreasing the vibration levels. The vibration test only lasts a minute, and during the test, the table sweeps from low to high frequency movements. As you can see in the video, we used a hula girl figurine as a visual to detect table and test article movement during the test. At low frequency, like bobbing up and down in a boat, the hula girl does a slow sway. In fact, she doesn't appear to dance at all. You can, however, see the actuators that control the table on the right move up and down. When we sweep to a higher frequency, this is much harder to see on the table. That's why we use the hula girl. The actuators look like they're stopping, but they're moving so fast you can't see it. Notice the hula girl start to shimmy. The test is performed as expected, and we concluded that the structure is designed to survive the launch environments. The development of the European Service Module is an important next step in our exploration goals. Testing that has been conducted to date has helped verify the integrity of the design. The flight model is currently under production and is expected to ship to the United States next year. The Orion launch is in 2018, the first unmanned mission to demonstrate that systems will operate as planned. Our destiny is to explore the heavens, but we must make it safe for our crew. Everything we are doing today ensures that the vehicle is designed well and crew can survive and return home safely. Today is a stepping stone and our proving ground. Our mission has started, so please join us on this exciting journey to Mars. I'd like to thank everyone that supplied me with video, photos, and data. Special thanks to Amy Crane and Carol Ginty, who supported this presentation. There are many to thank in the Orion program, as well as the European Service Agency and the Airbus Defence and Space. Thank you.